All right, everybody, welcome back. We are going to be working with 7th grade and focusing on equivalent expressions today. So, taking a look at this, this brings me back, right? And if you haven't heard me in other videos, I'm currently a high school teacher, right? But I used to do middle school for quite a bit, and 7th grade was essentially where I started. And yeah, they bring me back to a while ago. But same type of questions. Okay, these are fairly new examples, but they're the same style. Um, so let's see what we have. I don't see a lot of multiple choice, guys. I see one calculator. I see enter the value, the value, the value, almost like we're solving things. Um, but not really, because we're just trying to make the expressions equivalent, and the way we make them the same is by substituting the letter, okay, with an actual value. So let's see what I'm talking about as we start our quiz right now. So choose an expression that is equivalent. Again, equivalent, the same as that. So one of the things I hate is parentheses. To me, I am a visual learner, and when I see parentheses, it's like so much extra stuff that is unnecessary sometimes. So I always tell the students, you know what, let's get rid of it. So parentheses in this case means multiply right there. I'm going to go left to right. So we're going to multiply negative 2 times x. That's just negative 2x. So this is where it gets trippy, right? Because everything else, I'm going to leave it the same. In order of operations, I got to do multiplication before I can do any subtraction. So I got to multiply that, and I got to multiply that because there's no division. So I'm going to use multiplication. And again, if you heard me in my other lessons, it's multiplication or division, whichever comes first, left to right. So I got to take care of that, and I should have taken care of that. So I'm going to have negative 2x minus, negative 4 times negative 5. Can I use a calculator? No. So do you know what a negative times a negative is? Hopefully you realize that's a positive. And 4 times 5 is just 20. So now we have an expression. Negative 2x minus 20. Which one of those is going to be it? And in this case, it's just A. So not that horrible. Now here's your test taking strategy I recommend you do. And I always say, right, I know it looks like a lot of busy work, but in the long run, it's actually way faster and it's way less of a headache, because you guys can write everything on paper a lot faster than trying to keep everything together in your head. There's way too much info here sometimes. So what am I talking about? So first of all, you have a select all or choose all. Are you going to pick 1, 2, 3, or 4 options? Well, you're not going to pick 1 because then it would have been multiple choice, right? And it's super, super ridiculously super rare to pick all of them. And as I said before, my same old joke, right, that I will probably say till I die, it feels like, sometimes as a teacher. And if you're a teacher, you know what I'm talking about, because we say them a lot, okay? Don't lie, because you know we do. The joke is, when I was your age, right? Well, when I was your age, guys, we used to have that stupid answer that was all of the above. I hated that answer, okay? You guys don't have to deal with that anymore, really. Okay, at least not right now in what year is this? 2025, okay? So in other words, after all that, we're going to probably pick 2 or 3 options, okay? Now what I'm going to notice is, as I like to examine my answers, those 2 only have 2 terms, and these have 3 terms. The thing that I hate as a student is when I do my work, because remember, I'm a student first, and I have to do all this myself, right? I'm doing the work, and then I can't see where the answer is in my work. Like, they did it differently, in other words. And that's why I always tell students, like, I don't care how you did it. I'm like, everybody thinks it differently as long as we get to the same place, aka the answer, and you didn't get lucky, okay? You didn't luck out. So that ends up being a problem, because a lot of our questions, we have to play teacher, right? Like, you have to say, where did this person make a mistake? And I'm like, oh, I did it differently. I don't know. But what I do know is how to get to the final answer. So here's the strategy, right? Whenever they tell me to choose all expressions equivalent, well, I'm just going to find the answer myself. So what do I know about expressions is I need to simplify by combining like terms. In other words, x's with x's with x's with x's, and then units, aka numbers, with numbers. So if I have all my x's, I'm going to have 2 plus 3, that's 5. 5 plus 7 is 12. 12 minus 13, wow, really? Okay, so I'm going to have 12 minus 13. The 13's bigger, so it's negative 1x. And then for my units, I have negative 5 plus 11, or I have 11 minus 5, so that's just a 6. So this is my answer. And notice right away, boom, that one is done. Okay? So the thing is, some of us are going to be like, oh my God, where did they get 12 from? I don't see a 12. Where do they get 5? I don't see a 5. Where's a minus 2x? I don't see a minus 2x. But here's the thing, right? This is why it's beautiful. You guys are really good at just adding and subtracting and multiplying. Hopefully multiplication, but adding and subtracting for sure. All we're going to do is simplify this as well. So x's with x's, units with units. 12 minus 13 is negative 1x plus 6. 5x plus 2x minus 2x. Those are all the same terms. So 5 plus 2 is 7. 7 minus 2 is 5x. Which one ended with this answer? Only that one and that one. So how many did I end up picking? 2. So do you see how much easier it was just to get the answer to the other one? Yes, I had to do a little bit of work, but I didn't have to start freaking out and getting a headache over pretending like I knew what the person was doing in their head, you know? So this is way faster, guys. I know I always say it looks like it's longer because I did extra work, but it's actually way faster to write it down. Okay? All right, moving on. David was shown 2 expressions. I see a calculator. I'm going to bust it out. Okay, I'm not even going to think about it. Let's have that ready just in case we need it, or else why would they have it there? David was shown 2 expressions, 3 parentheses 6x minus 9 and 9x minus 6. David claims these 2 expressions are equivalent. That means they're the same. Because 3 plus 6x equals 9x and 3 minus 9 is negative 6. Okay, sure, okay, whatever. To show David that his conclusion is false, so in other words, David is wrong. Evaluate each expression when x equals 2. So when they tell me the word evaluate, they mean plug in. Plug in a number. And in this case, they gave me x equals 2. And that's another hint, right? Normally, isn't that basically an answer? Right? Like if I find x equals 4, that's an answer. X equals 3, that's an answer. So if they gave me x equals a number, not always, but sometimes I'm like, do they want me to plug it in? Okay? And in this case, yeah, they just want me to plug it in to prove them wrong. I'm a little confused. Like I said earlier, what is David thinking? I don't know. Okay, let me see if I can make sense of it. I just know that David is wrong. How do we prove it? Because David said that this, so 3 parentheses 6x minus 9, is equal to 9x minus 6. And what this thing is telling us is that it is false. That is wrong. They are not the same. That's why I'm going to put a slash through it. That is not true. So how do I figure it out? Let's just plug it in. Okay, that's fine. So 3 parentheses 6, everywhere you see an x, I'm going to put a parentheses. And then I'm going to switch it to a 2, but let me do the bottom one, 9 parentheses minus 6. And what was I saying? Where I see x equals 2, I'm going to switch that x to a 2. So let's put a 2 right there and a 2 right there. All right, so now I'm calculator. I'm going to copy that exactly how it looks. So I have a 3, I have a parentheses, I have a 6, and I have another parentheses with a 2. Close it. And then I put a minus 9 with a, and notice how they even told me, right? Is there a parentheses? Can you see how it's slightly shaded? Okay. So does that look like that? All right. Can you tell? Yes, it does. All right. So I'm going to press equals and I get 9. What about for the next one? So let's put 9 parentheses 2, close my parentheses, minus 6, and I got 12. So again, can you tell that the left side, I got 9. On the right side, right here, I got 12. Is 9 the same as 12 when I plug in 2? No. So that's why David is wrong. Okay? Now, if I go back just to see if you're a little lost where David screwed up, again, I'm going to do this myself as a student. And you don't have to copy this. So 3 parentheses 6x minus 9. I know parentheses multiply. This is special because there's 2 terms inside the parentheses. So I'm going to distribute. So 3 times 6 is 18x. 3 times negative 9 is negative 27. He got 9x minus 6. So where did he screw up? Can you tell? Just so we can play teacher and practice a little bit. Why not? I'll take advantage of the time since I have you and you haven't fast forwarded. Hopefully, maybe, probably. So what did he do? 3 plus 6. So instead of multiplying, right, 3, 6x minus 9, David said 3 plus 6 equals 9x. And then David said 3 minus 9 equals negative 6. So he didn't multiply when he distributed. He just said, oh, they're positive, so I'm going to add them. 3 plus 6, right? Can you see it's a plus 6? And 3 minus 9. That's where David screwed up. All right, next one. And these look very similar, so let's see the strategy here. Okay, same strategy. So I'm not going to try to explain it every single time, just once for the whole lecture here. So enter the value of a, so the expression, what's my first expression? 6 parentheses 7 plus x is equivalent, aka equals x plus a parentheses times 6. So here's what's interesting, right? Visually speaking, there's a 6 on the outside, and yes, technically, you're going to distribute, right? It's the same thing. They're trying to trick you or mess with you. Doesn't matter if it's on the left side or the right side, you're still going to distribute. Then I see that both sides have a parentheses, okay, and both sides have an x, a positive x. So what's the only thing that's missing? Can you tell that if all of those are the same, then the 7 has to be the same as a. So that's 7. So that's a visual thing, all right? Can you do this visually? Now I'm going to do it algebraically, or mathematically, I guess, like some of you guys would prefer. So I know that, like I said, I'm going to distribute. So 6 times 7 plus 6 times x, right? On the other side, I see 6 times x and 6 times a. Well, I get 42 plus 6 times x, and on the other one, I get 6 times x plus 6a. Well, if these two are the same, that means that this, whoa, wrong color, the 42 has to be the same as 6a. So 42 equals 6a. How do I solve for a? I'm going to divide both sides by 6. I get 1a. It doesn't cancel. I get 1a equals 7. Hey, look, that's what I got. So that's how we can do it algebraically, right? Same exact steps. I did the same thing right here, right? Distribute. It's something we should know how to do in 7th grade. All right, here's our next one. So let's see. I'm going to get all of this, 2x plus 4 plus 6x plus 8 is equal to 8x plus b. So I got to find b. What do I got to plug in for b to make both sides the same? So let's see. Parentheses don't matter because everything is a plus. So I'm going to have 2x plus 6x is 8x. Oh, I already see it. Do you see it? And then I have 4 plus 8 equals 12. On the right side, nothing happened, so I'm just going to leave that. So now can you tell it's going to be very similar to what I did here. I have 8x and 8x, so those are the same. So if those are the same, that means that 12 should be the same as B. So in other words, B is just 12. Not horrible, right? Not that bad. It looked a lot scarier than it actually was. So all you got to do is work it out, okay? Don't overthink it. Just do what you know what to do, right? If you see parentheses, distribute. If you see a bunch of terms, add and subtract them by combining like terms. All right, here's another one. Same strategy. They are equal, right? So I got 4x plus 12 is equal to 2 parentheses 2x plus c. I'm just going to work them out because it's a lot faster. So on the left side, nothing can happen. On the right side, I see parentheses, so I'm going to get rid of it in this case by distributing. So 2 times 2 is 4. There's an x there. And 2 times c is 2c. And this makes me happy because can you see already why I'm happy? I got a 4x and a 4x, which means that 12 should be the same as 2c. So if I know that 12 equals 2c, how do I solve for c? All I got to do is divide by, as I stall, 2. And 2, to be fair, 2 divided by 2 is 1. That's 1c by itself. And 12 divided by 2 is 6. And notice I can't use a calculator, right? I have not used it here. So actually I should probably just close that because not to get tempted here. So c equals 6. Next one. Oh yeah, it's the same thing. Oh yeah. So a little different though because I see minuses, so we got to be careful. So 13x plus 11. Actually, I don't want to get ahead of myself. Let me read it. Because sometimes they try to trick us by switching one little thing. So enter the value of d. Okay, so d, do I see? Yeah, it's right there. So that the expression blah, 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 blah is equivalent to the other expression. Okay, so it's the same. So those are in parentheses. Minus 7x minus 5 in parentheses is equal to parentheses dx plus 16. So here's the tricky part. These parentheses up here, everything was plus. So when everything is plus, I don't have to worry about parentheses. When there's a minus, though, it's different. The first parentheses doesn't matter, okay, because everything is positive. You know, there's technically a plus out there, right? But on the second one, what happens when there's a negative? Well, remember, you still technically have 1 right there, and it's negative 1 to get distributed, or the negative gets distributed. So if I have that, a negative 1 times a positive 7 is a negative 7x, and a negative times a negative will give me a positive 5. What some of you guys have probably learned as a shortcut is if you have a negative on the outside, what happens to all the signs on the inside? You just switch them, right? That's another way to think about it. Okay, so let's go back to the problem. Now that my parentheses are gone on the right side, I don't have to worry about them either because there's no minuses anywhere. So, combine like terms. 13x minus 17x. 13 minus 7 is 6x. 11 plus 5 is 16. Oh, I'm getting happy here. So can you see why? I already noticed that there's a 16 and a 16 on both sides. Therefore, 6x should be the same as dx. So if 6x and dx are the same, well, now it's an even more visual thing. Can you tell? If they both have an x, that means that 6 and d have to be the same. So therefore, d equals 6. And I forgot the little box. And let me check. I should have fixed it in the other one. Yes. Okay. So there we go. Not that bad. Okay. Let me just check. All right. Next one. Is this our last page? I think it is. Yes. All right. 3 more problems to go. Sweet. It's the same. It's the same. Okay. That's really cool though. I like this because if they're going to focus on this style of question, you've had so much practice that hopefully by now you're comfortable with it. Okay, I'm hoping. But let's do 3 more just to make sure. Okay, enter the value of e so that the expression blah, 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 blah is equal to this expression. Okay, let's write it over again. Let's not be lazy. 2.5x minus 3 minus, I see a minus there. Outside of parentheses, negative 5 minus 4.5x is equal to, and again, parentheses, do I really need it? There's nothing there. So it's just EX plus 2. So now, my first parentheses group, I don't have to worry about it. I can just get rid of them because there's no minus. But on here, I got to distribute the negative. So a negative times a negative will give me a positive 5. A negative times a negative will give me a positive 4.5x. And the right side, nothing happened. So what does this have to be? Well, let's see what's going to match and cancel probably, right? So let's see. 2.5 plus 4.5. So I always think about money. So $2.50 plus $4.50. So 50 cents and 50 cents is $5. Okay, so I'll add it to the 4. So 4.50 plus 50 cents is $5 plus $2 is 7x. Then I have negative 3 plus 5, or 5 minus 3. Guess what that is? Positive 2. So can you see where we're going with this already? It almost is identical to the one we just did. Why am I saying that? Because I have a 2 and a 2. So therefore, I should know that my 7x is the same as EX. And because they both have x's, you should hopefully realize that the 7 is actually the letter E. So yay, not that bad. Okay, it's pretty nice actually. All right, next one. Still no calculator, but that's okay. What do they want us to do? Enter the value of f so that the expression 9x plus f is equal. Oh, wait, I got 2 letters. Whoa, okay. Oh, no, it's been the same on the other ones. I don't know. I was freaking out for nothing here. I thought they were going to switch it on me. Only because we're at the end. All right, no, we're okay. So 3x plus 3 times 3. So parentheses on the right side, the left side, nothing happened. Parentheses means I'm going to distribute, so I'm going to multiply to everything inside the parentheses. So 3 times 3 will be 9, and there's an x stuck to it. And then 3 times the 3 with the number is just a 9. So then this is really nice already. 9x and 9x, which means that the f has to just simply be 9. So there it is right there. And finally, Junior claims, and we have a calculator. Let's bust it out just in case we need it. So let's see. Take that out there. Make it smaller a little bit. All right. Junior claims that the expression 2 parentheses 2x minus 6 is equivalent to 4x minus 6. Which statement explains Junior's mistake? Okay, so here's a test-taking strategy. I'm already looking at all the answers. It says the equivalent should be, and oh my God, the last one gets me so mad. So mad. I was like, why do they put that on the state exam? Why do they put that? It's obvious. And then every year I always get a bunch of you guys who write this. It literally says he's wrong. And I will have students be like, no, he's correct. The headache. Okay, he is wrong. So it can't be D. Okay, so just like I said, I'm not going to play teacher, right? I want to know what the final answer is, because guess what? Is the final answer that one, or that one? So let's see where I started. 2 parentheses 2x minus 6. What does it equal? So Junior said it was 4x minus 6. That is wrong. So I'm going to go ahead and do it myself. That means I'm going to distribute. And I'm going to get 2 times 2, which is 4x. And 2 times negative 6, which is negative 12. So which one of those options should it be? Can you guys see it already? Please. It's not 4x minus 4. It's not 0. It's that one. So what did Junior not do? Junior did not find the product of 2 and 6. What are they talking about? Junior forgot to multiply that. So Junior got 4x, but he just left the negative 6 alone. So can you see what the answer is? He did not multiply the 2 times the negative 6. Okay. That was it. 10 questions. That was one of the shorter ones, but you got to see a ridiculous amount of them were that strategy. Okay, that type of question. So hopefully you feel a little bit more comfortable, okay, after all these little mini lessons, but same structure, right? Same idea. Just work it out yourself, all right? And then you'll see the answers instead of trying to guess. All right? Until next time, guys.